Hello students, here I am going to demonstrate about transistor characteristics. Here in this transistor characteristics, we have to study input and output characteristics of this transistor. Here on this board, here we have two transistors, one is NPN transistor and another one is PNP transistor. On the upper elevated part we have four digital panels, voltmeter, this one is ammeter and this one also ammeter and voltmeter, and four resistors are given on this board and two power supplies given, one is 3 volts range, another one is 10 volts range. Let us see how to give the connections in this experiment. First we will see the input characteristics, then we will study about output characteristics. Mainly in this experiment we are going to study about input resistance and output resistance. You know already about this experiment in your theory classes. So now I will show you how to give the connections. Start the connections with the battery, 3 volts battery. Positive terminal of the battery is connected to resistor, first terminal. Resistor, another terminal is connected to the positive terminal of the ammeter, and the negative terminal of the ammeter is connected to base of the transistor, and emitter is connected to, this is the emitter terminal, is connected to negative terminal of the battery. After this we have to give voltmeter connection. To give voltmeter connection, resistor, one terminal is connected to positive terminal of the voltmeter and the negative terminal of the voltmeter is connected to source negative terminal. After completion of this part, input, we have to give output circuit connection. Again start with power source. See, positive terminal of the 10 volts source is connected to resistor, one terminal. Resistor, another terminal is connected to ammeter, positive terminal, and ammeter negative terminal is connected to collector terminal, and this already connection is there, inbuilt connection. We are doing this experiment in common emitter configuration, that's why we are using these two terminals. Common emitter, this one, this is emitter, these two terminals represents emitter only. We are taking this emitter for input and the same emitter for output also. So emitter, another end is connected to negative terminal of the source, and these two are pending. Now we will give parallel connection to this resistor. One terminal is connected to positive terminal of the voltmeter and the negative terminal is connected to source negative terminal. This is circuit connection. Now switch on the power. First keep both the knobs in the minimum positions. So you can see the same circuit diagram. Here I will show you. This is the circuit connection. This part represents input characteristics. This part represents output characteristics. By keeping VCE voltage constant, we have to take the readings in between VBE versus IB. This represents input characteristics. Once input characteristics completed, for output characteristics we have to keep IB value constant, have to take the readings between VCE versus IC. This is what we are going to do in this experiment. Now I will show you how to take the readings. You have to remember the circuit diagram also. Now first keep VCE, this one. We have to keep first 0 only, keep 0 only here. Take the readings by using this knob. Increase the voltage, VBE voltage 0.1, 0.2, 0.3. By increasing this voltage here, this current value also will change after some voltages that you have to tabulate. At 0.6 current started, at 0.775 the sharp rise in the current you can observe. Yes, you can see sharp rise in the current you can observe, so that you have to note down. So once these readings completed, next keep both the knobs in the minimum position and then keep VCE. Keep VCE 5 volts. Keep 5 volts or 10 volts, your wish. Again note the VB versus IB, how to take the readings. Here you can see again at 0.6 current started, at 0.7 sharp rise in the current you can observe. These values you have to tabulate in the tabular column. I will show you. Yeah, here you can see by keeping VCE 0, here these are the readings. By keeping VCE is equal to 5 volts, these are the readings. Sharp rise in the current takes place. By keeping VCE 10 volts, here these are the readings. Based on these readings you have to draw the graph. Yeah, this is the graph which represents input characteristics of the transistor. Take voltage values on x-axis and current values, base current values IB on y-axis in microamperes. Take the scale like this, 10, 20, 30 microamperes, 0.1, 0.2 like this. You can see the scale. This is the scale. On x-axis 1 unit is equal to 0.1 volts, on y-axis 1 unit is equal to 10 microamperes. How to mention clearly NPN transistor in common emitter configuration input characteristics. Okay, so you will get the graph like this. For 0 volts VCE 5 volts, VCE 10 volts, you will get the graph like this. Then we will see now output characteristics of the NPN transistor in common emitter configuration. Now keep both the knobs in the minimum position for output characteristics of NPN transistor. Now to study output characteristics of the NPN transistor, we have to keep IB constant. We have to take the readings between VCE versus IC. Okay, now see, keep in the microamperes range. For 10 only see this one, don't see this one. For 10 or 20 keep this value 10 microamperes. Now vary the VCE voltage by increasing the voltage 1 volt, 2 volts, 3 volts. Here this value is constant 0.04, that means almost 0 only it is showing. So we are getting constant value, you can observe. As you are increasing VCE voltage, here you can observe IC value is constant. Okay, after that again keep in the minimum position, this knob, and again put in the microamperes range. Put here 20 microamperes, and again change the mode to the milliamperes. Why? Because to take this IC, okay, we have to keep this one in microamperes. Again start 1 volt, 2 volt, 3 volt. This value is constant, 0.18 or 19 you are getting here. Whatever may be the value here, as you are increasing the voltage, yeah, the current value is not changing, that is constant here, you can observe. Am I clear? Now see, I will show you the graph. For output characteristics of NPN transistor in common emitter configuration, take either 10 microamperes or 20 microamperes. For 20 microamperes, here you are getting the readings like this. For 40 microamperes, you are getting the VCE versus IC values like this. These IC values are in milliamperes. Okay, these are in volts. Here you can see. Like this constant value you can observe. Okay, now I will show you graph, output characteristics graph, voltage versus collector current IC in milliamperes. You can see first the current increases and becomes constant. Here same constant value we are getting. Scale you have to consider like this. On x-axis 1 unit is equal to 1 volt, on y-axis 1 unit is equal to here 0.1 milliamperes. This is the output characteristics graph. So in this experiment we have studied input and output characteristics of NPN transistor in common emitter configuration. For this actually you have to calculate output resistance. For output resistance, delta VCE by delta IC is the formula. See you in the next experiment.